thing or the introduction and just use the inbuilt function and you're done. I'm not expecting all of you to be like that. So that is the reason this is not the right book. Okay, the detailing that we are doing in the class has to be understood and to be also to be applied in the labs. Okay, so that is what is expected from all of you. Okay. Um, Okay, now I'm going to share the screen and any of you, so Dhwani, am I audible? Am I clearly audible now? Dhwani, is this okay now? Dhwani, I'm asking, am I
Yes,
audible
ma'am.
clear? Yeah, okay, thank you. Uh, so I'm expecting one more student. Payal, have you joined? Payal, have you joined the session? Payal Saluja?
Yeah, I have joined.
Yeah, thank you. I'm sorry I missed to send you the request. Uh, yeah. Okay. So, Payal, this is our fourth class. Okay. We can conduct one or two classes for you or an hour session with you so that I can tell you the introduction and all. But for this is the fourth class, so I'm going to just do the revision. First two sessions were introduction, so there was not much which was covered. But in today's session, we have started in the previous session, we started with linear regression. I'm going to very quickly revise the content that we had done in the last lecture, and then we are going to go to the next topic, right? Or rather, we go ahead in the same topic. Okay.
Okay.
So is yeah. So all others who have been attending this class, can you tell me that do you need a small revision of this topic or was that okay? Like you understood? Anyone can tell me
Yes, ma'am.
what? Yes for what? Like you need a small revision or no? You understood? Yes means what?
Like going through the main concept only.
Okay.
That
Right. So in the previous class, we studied about linear regression, and we said that regression means that you're trying to estimate the value of the given, depending upon a few dependent variables. So, for example, in this case, we said that this is the size of the house, and we are trying to predict or we are trying to find out that what will be the this is the size of the house. Based on this, what is going to be the price of the house. Now, so this is the house size, this is the price. So, machine learning is all about generalizing from the specific examples. So, these were the examples given, specific examples as in that what size of the house was sent or was sold and what price. So, that gives us the data set. Now, we want to generalize it, and generalizations, the outcome of the generalization is the equation of the line or a model. In this case, that model is the equation of the line. This equation of the line is going to give us a model where we given a new value, which is the size of the house, and the output that we get is the price of the house, right? Now, how do we define that what should be the best model, right? So the concept we understood that there is a specific instances and we are trying to find out the general equation, right? Now, what is going to be the best solution, right? We discussed about it. The best solution is something that fits best. Now, what is the definition of something that fits best? The fits best is not something that passes through most of the point. It is the best solution is something which is closest to most of the point or all the points, which fits the all the given examples in the best manner. Now, to find out that what is the best solution, we say that some solution or some model, in this case the straight line, which has the minimum distance. So in this case, in case of linear regression, we will define an objective function, and that objective function says that the distance of these points from this line has to be minimum, right? the distance of this point or the error, right? So some point on this line is going to be something which is going to be the predicted values, and what actually is given is this. Now the difference between this and this is going to give us the error. We also discussed that there is something like a positive error and a negative error. Now, in this case, for example, our predicted value is higher than what the actual value is. So, if I minus my actual value, right, the actual value minus the predicted value. In this case, the value is going to be negative. In this case, the value is going to be positive, right? If I add both of them, then this gives me a zero or a value which is nullified, basically, but which is not appropriately representing the scenario, right? Why? Because an error is error. So I'm interested in adding all the errors, which is either a negative error or a positive error. Rather, I'm interested in knowing how much does it deviate from the actual data set given. So in that case, we are going to use the squared. So the best fitting line is this. The best fitting line is this, which is closest to it. Now the entire exercise is finding out this best fitting line. So for that, we said that this is our j theta, which is an objective function, which is yi minus this yi is the actual value given minus this is the predicted value. This is the predicted value. So the actual value is this one. So I said that this is y, this is x, and I is this are these indices, right? These indices are I. So when I'm saying x1, I'm referring to in x column the first instance. When I'm saying x10, I'm referring to the 10th value in the x column. And similar is the case with y, right? So yi, how do I get the yi? I get yi, or suppose to, y3 cap is equal to h theta x3, which is equal to theta 0 plus theta 1, and whatever is the value of x3. Now, what is x3? x3, we are going to get it from here. So, x3 in our case, for example, is 1, 2, and 3, so 39. Right? So, we are going to substitute 39, right? Plus theta 1 plus theta 0. Now, what are the optimal value of theta 0 and theta 1 is what we were trying to find out. Okay, this is what was our exercise, and I said that because this is average, therefore 1 upon m. Why did we keep 2? I said I'm going to discuss it in a while, right? Why we have 2m? I said that I'm going to discuss it in a while. Right. Then we talked about a curve like this, where we said that given, assuming that our theta 0, right? So we actually plotted this equation. How did we plot this equation? We assumed that our theta 0 is, for example, 0. It means that our line is passing through the origin, and therefore there is no y-intercept. So our line is like this, can be like this, can be like this. Sorry. So can be like this, or can be like this, or can be like this, and so on. But it is always passing through the origin. It can have any slope. So basically, my equation of the line is equal to y is equal to theta 1 x. Now, if I am saying theta 1 x, and here's what we are trying to plot, so for different value of theta, what is my j theta? That is what we plotted. For different values of theta, what is my j theta? We took an example. How many of you did actually worked out the example that I had solved in the class last time? How many of you actually worked out? Anybody who worked out that problem? Hmm? Anybody who worked out that problem?
Yes, ma'am.
Yes,
You?
ma'am.
Okay, very good, very good. So I think I have that in my screen now. Let me check if I have that worked out problem here. Yes. So we actually did this problem. I'll share the screen. So we worked this in OneNote, and we said that we had a data set, and that data set I think I rubbed that data set. So we took different values of theta. We took value of theta is equal to 1. We took value of theta 2 is equal, theta is equal to 2, theta is equal to 3, theta is equal to 4. And then we substituted it at here, and then we tried to plot the theta, and we saw the equation is, the plot is something like this. Okay, so this was the plot that we have done in the class, in the previous session. Okay. Now, I also said, I was also talking about that what this theta would mean. This slope would mean. The slope is actually the difference of the next value to this value, which is also known as the first derivative, right? So first derivative, if you see, I said that first derivative is equal to, if you remember the definition of d by dx of fx, right? D by dx of fx is equal to f of x plus delta x minus f of x divided by delta x. This was the definition that we were told in grade 10 or 11 when we were introduced to the concept of differentiation. And that means it is a difference of the next value, the value of the function at delta x point minus the value of the function at the x point divided by the delta x, right? So that's how it is, right? So if it is an increasing function, it means the value at fx plus x plus delta x is going to be higher in comparison to this. So if it is an increasing function, I'm going to have a positive value. If it is a decreasing function, the value at delta x, so this is my x, this is my x, this is my x plus delta x. So if you talk about x plus delta x, the value of fx at x plus delta x is smaller than the value of fx at x. Therefore, in the while this is a decreasing function, in case of decreasing areas of the function, it is going to have a negative slope. Negative slope. So the point that is also, so difference is also known as the tangent at the point, at that point, right? That is also defined as d by dx, right? So the tangent at that point is going to be having a positive slope. If it is the increasing side, it is going to have a negative slope when it is a decreasing side. And what it is going to have, it is going to have an infinite slope, right? Or rather, it is going to be parallel to your x-axis, because, or rather, it is going to be parallel when your slope is here, right? So positive, negative, and there is a zero slope, right? There is a zero slope. Now, zero slope means a point where you have, when the value is from negative is becoming positive. So if in number line, if you see the value is becoming from negative to positive, there is a point at zero. A zero is a point which is found to be a minimum value, because the value is decreasing, decreasing. At this point, it started increasing. Therefore, that was the minimum point, right? That is the reason we equate d by dx to 0, because that's the point where your slope is equal to 0, or the tangent is parallel to your x-axis. Okay, so up to this we understood the concept of differentiation. We understood the concept of our j theta with respect to the parameter theta. Okay, now we also have to understand this figure. Now this figure says that when your attribute, right, when you don't have to learn just one parameter, rather you have to learn two parameters. So you don't have just one theta 1, rather you have a theta 0 and a theta 1. Okay, please interrupt whenever you lose a link or you feel that you are not able to connect. Okay, please stop me, interrupt me, and ask me to revise the moment you feel that, because these are the initial topics which are going to make the foundation. So if you feel that okay, here you are not able to connect, please stop me, interrupt me, and we can go again. Okay, it is okay if we spend a little more time in these topics, and in the later points, in the later sessions, we can go a little faster, right? Not a problem. So when there are more than one parameters, theta 0 and theta 1, you can see that this plot, the plot in the two dimension was that when you have only one parameter, which was theta 1, and corresponding to it, you had a theta, you had a j theta value, and here the parameters are theta 1 and theta 0, and corresponding to these two, you have a bowl-like structure. In real life, the situation is neither going to be like this nor going to be like this, right? The situation is always going to be multidimensional most of the time. Multidimensional means that you have so many parameters based on which you want to predict something. For example, if you want to predict that how much rainfall it is going to be today, it is not just the humidity, it is not just the temperature, it is not just the amount of cloud cover, it is not just the wind speed, it is going to be all. So you're basically, if you talk about equation in this case, then your equation can be equal to, if you're talking about a linear equation, it is going to be theta 0 plus theta 1 into humidity plus theta 2 into wind speed plus theta 3 into temperature plus theta 4 into cloud cover and so on, right? So you have four parameters. So how many parameters? Theta 0, theta 1, theta 2, theta 3 and theta 4. So four parameters. It is impossible to visualize in more dimensions. So we are just trying to understand in one dimension. In when your attribute is input attribute is only one dimensional, when your when your parameter that you want to learn is only one value, when your parameter is only equal to two values. Okay. So here the value is theta 0 and theta 1. Okay. So am I clear up to here? Am I clear up to this point?
Yes, ma'am.
Right. Now, so we are talking about a linear equation. The output of this algorithm is going to be an optimal value of theta 0, theta 1, theta 2, theta 3, and theta 4. These are going to be the optimal values, which is going to give us a very close, a very reasonable estimate of a y, for which for an unknown humid value, wind, temperature, and cloud cover, we do not know that what could be the amount of rainfall. So if we have good examples, we will be able to get a good estimate and a good values of parameter theta 0, theta 1, theta 2, theta 3, and theta 4. Okay. Now, this is a concept when you do not actually have a function where you have multiple minimas and multiple maximas. So you have a theta 1 and your j theta values increasing and decreasing with the changing values of theta. So in this case, this is known as the local minima and this is known as the global minima. This is the actual minimum, but this is the minima because it is decreasing and then increasing again. So this is known as a local minimum. So this is a local optimum, this is a global optimum. Even if we are here, we are interested in not here we are actually not going to deal with such problems now. Okay, okay. Now, what does the gradient descent algorithm says? The gradient descent algorithm says that I am going to update. Should be updated the gradient descent algorithm says that I am going to update right in the function as we have seen a equation like this, that if I have started with a theta 0 here, then or rather a theta 1 with this value, then my next theta 1 should be moving this side or this side, right? Depends upon that what is the slope at this point theta 1. If the slope is negative, then then what will happen? If this is a negative value, if this is a negative value, then actually there is going to be addition in the theta j. It means I am going to move this side. If currently I am here at this point, this has got a positive slope. A positive slope means in the current value, the some part of value is going to be decreased, and this decreasing means I am moving this side, right? So to move this side for searching the minima or to move this side for searching the minima is something that is decided by one factor which is known as the gradient of the function. Now, because this function j theta 0 theta 1 is a variable in two is equation in two variables, so we are going to find out the partial derivatives. Partial derivatives means finding out d by d theta 0, j theta 0. So this is a partial derivative of the equation j theta 0 theta 1 into alpha theta 0 theta 1, right? So this is the and this is how we are going to derive that how do we get the value. But for now, I hope you understand that this is going to regulate, the slope is going to regulate that whether we are going to the positive direction, or we are going to increase the value, or we are going to decrease the value. So how does this method start? We assume any value of theta 0 and theta 1, random value of theta 0 and theta 1. We find out that at the point where I am standing, what is the slope, whether it is increasing or a positive slope or a negative slope. And depending upon the slope at that point, we would define that whether I should be increasing or I should be decreasing the value of theta j. Okay, I'll talk about these 2 points in a while. Okay, right. Mm, yeah, so let us derive this equation. Let us derive this equation. So we have a theta j, right? I'll derive it here. So we said that our theta j. Now this where this j is coming from, please understand that this theta j, the subscript for theta is corresponding to like this: theta 0 plus theta 1, x 1 plus theta 2, x2 plus theta 3, x3, right? Where x1, x2 and x3 has got nothing to do with the attribute, with the instance. Rather, they are the attributes. So, for example, if I say that x1 is the humidity, this is the wind speed, and this is temperature. So this becomes my x1, this becomes my x2, and this becomes my x3, right? And this is the amount of rainfall that happened in amount of rainfall, or which is equal to y, right? There is going to be only one y, right? So the amount of rainfall were suppose zero point 0.5 inches when the humidity was 90 percentage, wind speed was suppose 30 kilometers per hour, temperature was 45 degrees centigrade, and so on. So I have values like this. Okay. Now when I am saying x11, I mean to say in this column the first value. If I'm saying x21 means I'm talking about this value. When I'm saying, so this is something which is related to the column number, and this is something which is related to the row number. I hope this is absolutely clear. Okay. Now I'm saying that the equation, our relation is going to be y is equal to theta 0 plus theta 1 plus theta 2 plus theta 3. Okay. Now, if you talk about this, then I'm saying that my theta is going to be updated in this manner, which is theta j minus alpha into d by d theta j of j theta 0 theta 1. So where j will have value 1 and 0. Now let us derive that what it is going to be. We said that my j theta 0 theta 1 is going to be my actual value of y, right? Summation of yi minus y cap I, okay? का होल स्क्वायर डिवाइडेड बाय 2m. ठीक है, ये हमने इक्वेशन देखा. अब इसको देखें 1/2m into, let us replace this yi by the equation itself, by the equation of this. It is going to be yi minus theta 0 plus theta 1 xi. is only one variable here, so I'm not using a column script here. I'm not using a column script here. So this is what is going to be my equation. So yi minus, you understand where I get this from? Now when I differentiate it with respect to d by d theta, d theta 0, if I differentiate it with this 1 upon 2m, what I get, because this is square, this is whole square, so this becomes twice of summation of twice of uh, yi minus theta 0 plus theta 1 xi, okay, and then I'll differentiate it again because I'm differentiating it with respect to theta 0 into 1. You get me this? All of you understand that how do you derive this equation?
Yes, ma'am.
Yeah,
Yes.
anybody who has any doubt in this differentiation? Anybody who has any doubt in this differentiation? Okay. If you have any doubt, please ask now. Okay. Now we can now cancel this 2 and 2. Now this is the reason I said we have to keep 2 and 2 because this makes the entire equation easier and convenient because when you differentiate it, it is equal to this minus this, right? And here what has been done? I've kept y minus theta 0 plus theta 1 x and instead the value
Excuse me, madam. Your voice is not coming. Very low.
okay. How about this? How about this?
It's better now. It's better now.
Okay. 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 So now we are going to similarly derive it for theta 1. Okay. I'll use a notepad, OneNote for that. I've already shared that, so I'm going to use that OneNote. Okay. So there are two terminologies which are used, which is saying that my j theta 0 theta 1 is equal to 1 upon 2m into summation of your y cap or h theta. They are same, right? The word h is used because it H means a hypothesis. H means hypothesis. Hypothesis is that we are assuming that this is a good model, right? So we are saying that H theta minus y I square. Okay. Now when I am saying this h theta minus yi square, okay, I can interchangeably write it as 1 upon 2m summation of y cap minus yi whole square. Okay, this two are one and the same. Okay, I'm sorry. This two are one and the same. Yes. Okay. One and the same. Okay. So when I can say y cap I minus yi, or writing this is okay. Now, as you know, this y cap or h theta can be written as h theta is equal to theta 0 plus theta 1 x. I'm going to write it as j of theta 0 theta 1 is equal to 1 upon 2m summation of theta 0 plus theta 1 x minus yi whole square. Now to update my theta value, we have said that theta 0 is equal to theta 0 minus alpha into del by del theta 0 of j theta 0 theta 1. Okay, and I'm saying that this was theta 0, so this is updating the value, and my theta 1 is equal to theta 0 minus alpha into del upon del theta 1 into j of theta 0 theta 1. Okay, so this is the way I'm going to, sorry, theta 1. Okay, and differentiation. So now our job is to partially differentiate this j theta 0 theta 1 with respect to j theta 0. When we differentiate it, what we get, del upon del theta 0 of 1 upon 2m into theta 0 plus theta 1 x minus y I xi yi whole square, right? If I differentiate it, what I equivalently get, I get 1 upon 2m summation of 2 into theta 0 plus theta 1 x minus yi into 1. Okay, and then if I substitute this here, what this is what is del by del theta 0. Now similarly, del by del theta 1. Please tell me what is going to be the answer for this. Del by del theta 1. Del by del theta 1. What is going to be the equation? What is going to be the equation? Please differentiate and tell me.
Ma'am, it will be 1 by m into summation of theta 0 plus theta 1 x minus y of I whole into theta 1.
Whole into theta 1.
Yes, ma'am.
Okay. Okay. Whole into theta 1. Okay. How many of you agree with this?
No, ma'am. I think
Ma'am, it should be whole into
Ma'am, it should be
X.
X.
X1.
Whole into x1 or xi, right? Isn't it?
Yes, ma'am.
Yeah. Why not theta 1? Because we are differentiating with respect to theta 1, not with respect to xi. Okay. If we were differentiating it with respect to xi, then it would have been a different scenario. Am I clear? The girl who uh,
Yes, ma'am.
yeah, so we are differentiating it with respect to theta 1, not with respect to x. Okay, so it is going to be into xi. So this is what is the differentiation, and now we shall write the final equation. The final equation says it is equal to theta 0 is equal to theta 0 minus alpha into 1 upon m summation of theta 0 plus theta 1 x minus yi. This is going to be the update function for my theta 0. For my theta 1, the update function is going to be theta 1 minus alpha into 1 upon m summation of theta 0 plus theta 1 x minus yi into xi. Am I clear? Am I clear?
Yes, ma'am.
Yes, ma'am.
Yeah. Now, what am I going to do is that I'm going to solve a problem which is going to update my value of theta 0 and theta 1. Okay. And then I'm going to talk about the importance of this alpha. Okay. Not now. But first, we will understand that what we have derived, how does it actually work? How does it actually execute? Right. So let us take my x and y, right? X and y, and the value of x is suppose 1, 2, 3, and 4. Let us take just 4 values for now so that it is convenient to solve it. Okay, and the value of y is the value of y is 12. And so suppose what I'm trying to do is I'm trying to say that my y is equal to 10x plus 2 with a little bit of error here and there, right? So suppose this is without error. So this becomes 20 plus 2 is 22. So let us take it 21. This is 30 plus 1, suppose. 30 plus 3. So this becomes 33, and this is 40 plus 40. Okay, so these are my 4 instances which are given. Okay, we initialize our theta 0. Okay, instead of making it 10, let me make it 1. So this becomes 1.2, this becomes 2.1, this becomes 3.3, and this becomes 4. Okay, so these are the values, right? So let my so the equation that I'm looking for, my h theta will be equal to theta 0 plus theta 1 x, right? This is what I'm interested in. Let me initialize this theta 0 and theta 1 with 1. Let my theta 0 is equal to 1 and my theta 1 is equal to 0, suppose. That is how I make any random value and initialize it. So let us initialize with this equation. Now, how am I going to update? What is going to be my next value? My next value is going to be like this. So my next value of theta 0 is going to be, I'll have to calculate this theta 0 plus theta 1 x for all the value of x for the current value. So this is 1, this is 0. So my this is basically my j theta, and this is basically my h theta, right? This is basically my h theta. So we will calculate h theta. H theta is going to be, we'll substitute this 1 in the equation which is as per the current value of theta 0 and theta 1. So what this gives me, this gives me 1 into 1 as 1, 2, 3, and sorry, it gives me 1, 1, 1, and 1. Yes, it gives me 1, 1, 1, and 1. Yes or no? You understood how did we
Yes,
get this?
ma'am.
Yeah, everyone,
Yes, ma'am.
everyone.
Yes, ma'am.
Yes, ma'am.
Okay, so the value that we get out of h theta is this. Now we are going to subtract it from the actual y given. So what is our yi? So h theta minus yi. So this column minus this column, right? So it is 1 minus 0.2, that gives me minus 0.2. This gives me 1 minus 2.1. This gives me this gives me minus 1.2, and this gives me minus 1.3, and this gives me minus 3. So this is, we are going to add all these values. If we add all these values, what do we get? We, this is 2.3. Please calculate and tell me. Please calculate and tell me. So to
5.7.
Okay, so to update my theta 0, it is going to be the current value of theta 0, which is 1, minus, let me take alpha value as 0.01 for now, divided by m. What is the value of m? What is the value of m?
4.
4.
4,
4.
right? 4 into summation of minus 0.2 plus minus 1.2 plus minus 2.3 plus minus 3. Okay, and this is going to give me, is equal to 1 minus, calculate this and tell me the answer. Yes, please.
1.21.
Sorry.
1.21 whole theta 0.
No, 1 minus how much?
Point,
This is
uh,
0.01 divided by 4 into summation was 5 point something, somebody said, isn't it? 3 दो 5 6 6.7 basically. This will be 6.7. This will be 6.7. So multiply this 0.01 into 6.7 divided by 4. Come on.
1.01425.
Sorry.
1.014.
This becomes first of all plus, and
Yeah.
this addition is 0.425.
This addition is 0.01425.
0.01425.
1425.
0.01425. Okay. So if we add this, what the final answer of the slope that we get is 1.01425. Okay. Our actual value should have been somewhere equal to 2, right? So we are going towards it, right? We are going towards it. If I keep this alpha value instead of 0.01, if I keep it zero point 0.1, right? I keep it zero point 0.1, this entire addition, which is currently 0.01, would have been, the final value would have been 1.1425, right? So I want to go towards 2, and I am moving towards 2, isn't it? I am moving slowly, but I am moving towards 2. Now let us calculate my theta 1. Okay, my theta 1. Theta 1 currently is 0, right? So theta 1 is equal to 0 minus 0.01 divided by 4 into summation of what? Summation of, it is this. If you see this equation, theta 1 should be equal to, yeah, should be equal to theta 1x minus yi into xi, right? Into xi has me. तो ये जो हमने फाइंड आउट किया है, ये जो वैल्यू है, take the eraser and make it a little bit cleaner. Okay, now let me rub this on. Okay, into xi. Now, so now I have the equation which is h theta minus yi. Now I need to multiply it with xi and get the final value. So this is what I've already calculated. Into xi is this. So minus 0.2 into 1 makes it minus 0.2. 1.2 into 2 makes it minus 2.4. This is minus 0.9, 6.9. This is 12. Okay, this is what I get. Now we will update it. Okay, so now if I have to update it, can someone remember these values, please? 0.2, 2.4, 6.9. So the values are minus 0.2, minus 2.4, minus 6.9, minus 12. Isn't it? Yes, yes. Okay. Now, everybody got what we are doing here? Everybody is getting what we are doing here?
Yes, ma'am.
Yeah. So now 0 minus, because this is minus, this will be plus. Add, multiply, and tell me. Add, multiply, and tell me. We have already taken 3 minutes extra, so I need to wind up quickly.
0.05375.
Okay. So 0.05375, something like that. Okay. Yeah. So now again I am making it a point that had this alpha been instead of alpha instead of alpha is equal to 0.01, if I would have taken alpha is equal to 0.1, my final value when alpha is equal to 0.01, the updated value has reached 0.053, and if had it been alpha is equal to 0.1, I would have reached 0.53. Where I want to go, I should be going approximately equal to 1. I should be approximately going to 1 because that is what we thought. It is x plus 2, and accordingly we formed our relation. And I am trying to find out an optimal value, and what we see is that if I take a larger value of alpha, I go to my equation, or I go to my optimal value a little quicker in comparison to if I take a smaller value of alpha. Okay, so from here we are going to again proceed, and we are going to take our discussions further um, from this point. Okay, any queries? Any queries so far? No, I am not dividing, Mohit. You said that why we are dividing every value of y by 10. And the reason I did it because just to make my calculation a little easier. Initially, I said that let us take the equation is equal to y is equal to 10x plus 2. Then I said, no, let us not take this, rather take it as x plus 2. So I divided the value with 10 actually. Okay. Am I clear?
Yes, ma'am.
Yeah. So even with that standard, the values are not right. Yeah, the values are not right. Okay, no
Okay,
problem.
ma'am.
But हाँ बोलिए please.
Ma'am,
Ma'am,
we have lab.
value of alpha,
हाँ
we have to assume the value of alpha.
मतलब नहीं समझी मैं आपके.
आपने alpha की
Yeah,
value
yeah, it is a
0.8
parameter. Yeah, yeah. We have to assume that. We don't learn it. We have to assume it. Yeah. Okay.
Uh,
We are
Hello,
going to
ma'am.
take it further in the next class and talk about alpha in detail. Yes, yes, please.
Ma'am, we have lab session for CSE student
Yes,
today.
today
We
we
can
have
share
lab
the
session. Yes, both the classes, data science and CSE, because the two groups have been merged for today's lab session now. So this is going to be true for all the coming sessions. DS and CSE, both of them will have a lab session today, Monday.
So is timetable going to change or this
Yeah,
is
no, the
fixed for
timetable
you?
is already changed. It is also changed. Because you don't have anything between 2 to 4, isn't it, today?
Yes,
Hmm?
yes, ma'am. Yes, sir. We don't have any.
Yeah. So that is the reason the timetable is changed. Okay?
Okay, ma'am. So
Yeah. हाँ बोलिए.
can you share that updated timetable with us if possible?
वो तो टाइम टेबल कोऑर्डिनेटर शेयर करेंगे. ठीक है, बस यही स्लॉट चेंज हुआ, और कुछ चेंज नहीं हुआ.
Okay, okay, then no problem. Okay.
हाँ ठीक है.